I would like to first start by thanking Mr. Thompson and Mr. Fry for presenting a math lesson in their social studies classes. We appreciate the opportunity to do some last minute review before you guys do an awesome job on the air test tomorrow. So for today, our math lesson is going to be around slope and y-intercept. What are our goals for today? Well, we want to be able to find the slope and y-intercept of a line when given 2 points on that line. We also want to be able to write a slope-intercept equation when given 2 points on a line. And finally, we want to be able to use a slope-intercept equation to predict other values on a line. So very basically, we are going to find slope and the y-intercept when we have 2 points. After we have the slope and y-intercept, we want to write a slope-intercept equation. And then after we have that slope-intercept equation, we want to be able to make some predictions. So that is our goal for today. So in order to come up with a slope-intercept lesson, a math lesson that also related to social studies, I thought about the Civil War. And if you notice this map, it shows the different states that were part of either the Union or the Confederacy during the Civil War. Now, I am definitely not an expert. I'm not even American, so my grasp on American history is slim at best. But if we look at this map, we can see that the blue states were part of the Union. The states that are red were border states, and you can ask your teacher the significance of those states. And then all the ones in gray were considered Confederate. And if I'm not mistaken, all of the white states that have nothing in them were not yet states, they were still territories. So for the purpose of today, we're going to concentrate on the Union states. We are going to concentrate on them. And what I want to do is do a little bit of data analysis of the population of those states. So if you notice, the blue states have many different sizes. And I was curious to how many people lived in those different states. So what I did is I created a scatter plot. Now, during the Civil War days, I took the area of the different states, the Union states, and I also found their population, and I plotted them, as you can see. So, for example, if a certain state had an area of 30,000 square miles, all right, which would have been right here, and had a population of roughly 750,000 people, I found 30,000 on the graph and went up to right about where 750,000 would be, or 700,000, and plotted my point there. And I did this for all the states in the Union. Now, what's interesting is I thought I would see a pattern, but I really didn't. Here's what's interesting. This dot way out here represents California. This dot right here represents Connecticut. Now, for those of you who know anything about the size of the states, California is much larger than Connecticut, and yet in the Civil War times, Connecticut had more people in that state than California did. Maybe your teacher will be able to explain why that would be. So I didn't really have any pattern. I didn't have anything to go with. And in math, we call this an association. So we've got several types of an association. We've got a positive association where all the dots on a graph seem to be trending in an upward direction. Then we have a negative association where all the dots seem to be trending in a downward direction. But then we have something called no association, where there is no pattern at all. And I think our scatter plot of the Civil War was one of these. If we take a look at it again, we can see there's really no association that we can tell of. And that makes it really hard to draw any kind of line that matches the data. So I went ahead and I tried something different. I went ahead and found the population of the states in present day. So now we have a new scatter plot, and it's based on the area of the states and the population in them today. And you can see the difference. Now we have Connecticut way down here, And notice California is here, and I couldn't even fit it on the chart. So something has changed over time. What else has changed is you notice we seem to have more of an association or correlation. Most of this data seems to be trending in a positive direction. So what I did is I went ahead and drew a line called a line of best fit. So here we have a line of best fit, and it matches the data of our states today. There is always going to be some outliers. There's always going to be a few pieces of data that don't seem to fit. For example, I believe this is New York, and there is a ton of people that live in a state. And so that might be considered an outlier. But for the most part, most of them seem to fit a pattern. Once you have that pattern, you draw a line, this red line of best fit. And then what you need to do is you find 2 points on that line. And once you find 2 points on that line, there's a lot of things you can do. So here are the points that you're going to be working with. You are going to work with the points 100, 15, and the point 50 and 8. And what I want you to be able to do, if you remember back to our I can statements, I want you to use these 2 points to find slope and to find y-intercept. And then once you've done that, I want you to come up with an equation that matches this line. And then once you come up with an equation that matches line, I want you to predict, using that equation, how many people would be in a state that has an area of 65,000 square miles. So let's do a quick review. If I have 2 points on a line, how do I find the slope? Well, there's 2 ways to do this. The first way is to do rise over run. So if I simply draw a step starting at this one, going up and over, I can figure out how far I've gone up and how far I've gone over. So in this case, I've gone up 10 and I've gone over 5. So my rise over run is 10 over 5, which can simplify to 2. So our slope, in this case, equals 2. And remember, our slope is represented by m. So in this case, m equals 2. Okay, now, the next thing we're going to do is show you one other way to find the slope. If you don't have the convenience of a graph, there's another way that we call the change in y. Remember, this delta sign represents the word change. So the change in y over change in x. And to do that, we're simply going to take these 2 points and kind of put them in a little table. So I've got 8 and 12 and 3 and 2. We know the x comes first and then the y. So what is my change in y? All right, well, I've changed from 12 to 2, which would be negative 10, and from 8 to 3, which would be negative 5. So my change in y is negative 10. My change in x is negative 5. But remember, a negative divided by a negative is positive, so this equals 10 over 5, which equals 2, which is the same thing we got doing the other way. So our slope from the 2 points is 2. Now, how do we find the y-intercept? Well, the y-intercept can be very simple. If you have a graph, you can see where this line crosses the y-axis. And as you can see, it crosses right here. And so we can find the y-intercept that way. So there, or the B represents the y-intercept, and it looks like it would be 1 in this case. The other way that you can do it is you can, now that we know that the slope is 2, we can use y equals mx plus b, which is the form of a slope-intercept equation, and we can choose one of these values, either 3, 2, or 8, 12. Let's go with 3, 2 because it's easier. And knowing that this is the x and this is the y, we can substitute those in. So we have 2 equals, we know the slope is 2, and y is 3, and solve for b to find the y-intercept that way. So what I want you to do is the paper that you have in front of you, go ahead and try to solve for the slope, the y-intercept, and come up with an equation for this line. And then, as I said, we want to predict how many people would be in a state that has an area of 65,000 square miles. Good luck.